This lesson will be an introduction to triangles. Many of you have probably learned about triangles in classes before, like in elementary school, but this will put names with different shapes and explain why they are named that way and how they are classified. So let's start the slideshow. So to make it fun and kind of keep you guys interested, we're going to call this tricky triangles because triangles can be tricky. A lot of them look the same, and sometimes you have to measure in order to be able to really classify them with the other triangles that they belong with. Our little fish, how cute. Okay, so these are the types of triangles that we're going to talk about. Scalene, isosceles, and equilateral. All of these triangles are classified based off their sides. And then we have acute, right, and obtuse, which are based off of their angles. Okay, so the first one that we're going to talk about is the scalene triangle. The scalene triangle has three sides, and they have to be all different lengths. So no equal sides and no equal angles. A lot of you are always asking, like, how does this apply to real life? Well, with triangles, if you know what kind of triangle you're looking for and know what classifies it, then you'll see triangles in real life and you'll know, oh, that's a scalene triangle, that's an isosceles triangle. So for examples of scalene in real life, we have the sailboat sail, which you can see on the screen, and then a skateboard ramp. Now, one thing that I want to point out is the lines on the sailboat sail. Now, if you notice, there's one side has 3, one side has 2, and one side has 1. Now, the reason for this is to show all their different lengths. So, this one right here, it has 1, which means, and there's no other ones on the screen, so that means it's the only one of that length. And then the one down here that has 2, that means it's the only one of that length. And then the one here that has 3, it's all by itself. And that goes with what we say scalene triangles are. They have 3 sides that are all different lengths. Sometimes it's not easy to tell the different lengths and you have to measure them, but this one's pretty easy to look at and be able to tell. The next triangle we have is the isosceles triangle. This triangle has at least 2 equal sides. Notice at least. That's a keyword right there. We'll highlight that so we can see at least 2 equal sides. These can be acute, right, or obtuse. So if you look over at our example here, we see the isosceles in real life can be an Indian arrowhead, which is what is pictured, and then the roof of a house. So when you look at this Indian arrowhead and you notice that the 2 sides have the 2 lines on them, then that should tell you, oh, these sides are equal. They're the same length, and then one on the bottom isn't. So, I mean, if we wanted to, we could put one line, it's hard to see, but we could put one line there to show it's its own length. And then another example I have is the roof of the house. So think back to your elementary school days, and some of you might still do it, but when we drew a house, we draw our box, and then we draw our roof, which was a triangle. So if you notice, the sides are longer than the base. So we could go through a mark and say, oh, these are equal, and draw our little lines on them. So some of you might still draw your houses that way, and that's fine. But just think, next time you're drawing a house or you see a kid's drawing of a house, you'll look at the roof and think, oh, that's an isosceles triangle. So our next type is an equilateral triangle. So equilateral, it tells you pretty much what it is in the term equal. So for an equilateral triangle, all 3 sides are equal, and they're also equal angular, which means all angles are the same. And since the inner angles of triangles have to add up to be 180 degrees, 180 degrees divided by the 3 angles means that all angles are going to be 60 degrees. And this is a special case of an isosceles triangle because remember with an isosceles triangle, I said that there has to be at least 2 sides. Well, this is a special case because all of the sides are equal. So it's both an equilateral and an isosceles. And then in real life, we have our pool rack and then our road signs. So you can just think of this pool rack, it's the same shape. Think of it as like a yield sign. So all equal sides, all equal angles. The next triangles are the ones that are based off of their angle measures. So for an acute triangle, I think of this one, I think, oh, so cute, so little. So acute means that all three angles are less than 90 degrees. So when we look at this one, if you think of it, I know the top's not perfect, but think of this line. Oh, I don't know what's happening. Here we go. You think of this line going right across here, making it a triangle. And so all of these angles here, all these angles, it's hard to see the red, but all those angles are going to be less than 90 degrees. So examples in real life, a piece of pizza, which, like I said, isn't a perfect triangle, but it's close enough for you to get the idea. And then a Dorito. Next up are right triangles. These have one angle that is 90 degrees and the other two are acute, which we just learned means that they're less than 90 degrees. They're pretty easy to identify. A right triangle, it comes to a perfect, they meet perfectly in the corner and form where you can draw a little L, you can see. They're easy to identify because of that and because they'll have a hypotenuse, which is the longest side. So if we look right here, this is the longest side of a triangle, and notice that it's opposite our right angle. So that's one way to identify them. And then some examples we have in real life are a sliced sandwich and then wedge sandals. So guys, you might not be able to picture the wedge sandals, but girls, just think about if you're wearing a wedge. Do we want the part that's under our heel that touches the ground, do we want it to be a right angle, or do we want it to be like an acute angle to where our heel would be rocking against the ground because it doesn't form that solid contact with the ground? So next time you put wedge sandals on, you can think, oh yeah, Miss Giles told me that this is a right triangle, because everyone thinks about math when they're getting ready, right? So our last triangle we have is our obtuse triangle. So we had, I know you can see on the screen, but if you think acute had angles less than 90 degrees, right had angles that are 90 degrees, or had one angle that's 90 degrees. So obtuse must mean that there's an angle that's greater than 90 degrees. And if one angle is greater than 90 degrees, then the other two angles have to be acute. Obtuse triangles can be classified as scalene or isosceles. And then, see, they go in a triangle. Okay. Obtuse in real life, we have a coat hanger, which you can see in the picture. And notice the lines on the angles. If you see these are the same, so that means that those two are the same angle measure. And then this one up here all by itself, that's our obtuse angle, which is greater than 90 degrees, and it's the only one in that triangle. Another triangle. Okay, so now this is just a little review of what you know. So we'll go over all the triangles we just talked about. So we have our scalene triangles, where no sides are equal and no angles are equal. We have our isosceles triangles, where at least two sides are equal and at least two angles are equal. And then our equilateral, which has equal in it, means that all our sides and all our angles are equal. And then we have our triangles that we classify based off their angle measure. We have our acute, right, and obtuse. Acute triangles can be isosceles, scalene, or equilateral, and angles are smaller than 90 degrees. And then our right triangles can be isosceles or scalene. One is 90 degrees and the others are less than 90 degrees. And then for our obtuse triangles, one is they can be isosceles or scalene, just like the right triangles, and then one is greater than 90 degrees and the others are less than 90 degrees. So that's just a really quick overview of the types of triangles. If you still feel a little lost on that, then you probably want to go back and review, because the next time we meet in class, we are going to have a quiz on it. This and some other videos that will help you are posted on our Weebly website, so that way you have all the resources you need to learn what you need and get a really good grasp of the concept of the types of triangles before we start building on our knowledge and learning other things and how to use them to solve in other shapes and other types of problems. So I'll see you in class.